Okay, what we're going to look at today is some very special cases for when we solve equations. So let's first of all start with a question on the right here. Now we're going to do just like we normally did. We're just going to distribute here. So 2 times 6x is 12x, and 2 times 5 is 10. And then we'll do the same on the other side. 4 times 3x is 12x, and 4 times -1 is -4. Now, I normally like to check if I've got the biggest number of x's on the left, and actually for this time that's the same, which is sort of unusual. So I'm going to try and bring my x's to one side. So I'm going to take away 12x from both sides. Now that one cancels, but then unusually that also cancels here as well. So what we end up with is 10 equals -4. So we don't have any x's at all. We also have a statement that makes no sense at all. Now when that happens, what we're going to put is, we're going to say this is no solution, because obviously 10 does not equal -4. Now we can also use that symbol as well, and that symbol means the empty set, which in other words means there's no solutions as well. So just a different way we can write it. So just be aware that all those three things actually mean the same. Now to remind you, the key you're looking for is you're going to have the same number of x's on both sides, but you're going to have different numbers. So when that happens and you get a nonsensical statement, you're going to say no solution. Now for our other one, we're going to set this up the same thing. We're going to distribute here, and we're going to distribute on this side too. And once again, you can see that we have the same number of x's on each side. Actually, we also have the same number this time. So when we take away 18x from both sides, that will cancel, and we get 6 equals 6. Now, obviously 6 does equal 6, so this is a totally different case. This is actually all real numbers. Now that means that any number will actually work for this. Now the phrase for this is actually an identity. We have the same thing on both sides of the equation. So we can say all real numbers. We can also say there's an infinite number of solutions. And the reason that works is, if we say an 18x plus 6 equals 18x plus 6, sorry. If I was to plug 0 into here, then I'm going to get 24 equals 24, which is obviously true. So 0 would be a good answer for this. If I was to plug 1 into here, excuse me, if I plug 0 into here, I actually just get 6. If I plug 1 into here, then I get 24 equals 24. If I plug 2 into here, I get 42 equals 42. So whatever number I plug in, I'm always going to get the same answer, because these are the same expression here. So when we have the same number of x's, we also have the same numbers. We're going to say all real numbers or an infinite number of solutions. If we have the same number of x's but different numbers, then what we're going to say is either no solution or the empty set. Now we can extend this idea to inequalities as well, and I've basically put up the same question, but for this one I've put greater than, for this one I've put less than or equal to. Now I've distributed on both sides. I'm going to subtract 6x from both sides as well. So what I get is 18 is greater than -3. So notice we've got no x's again, because we've got the same number of x's on each side, so when we collect terms they'll become 0. And then we have to look at this statement here. So is 18 greater than -3? Well, that's definitely true. So what we can say for this is true for all real numbers. So it's like your infinite number of solutions on the previous one that we looked at. Now if we do the same thing on the right hand side, take away 6x, take away 6x, then we get 18 is less than or equal to -3. Well, that's not true, because 18 is greater than -3. So what we can actually say for this one is, we can say no solutions, or we could use that symbol again called the empty set. So we have to look for answers, see if they're sensible or not. If something is true for all values, we can say it has infinite number of solutions. But if a statement does not make sense at all, then we can say there are no solutions, because obviously 18 is never less than -3.